So this is the first step of the recrystallization lab, which is the choosing the right solvent for the substance. So what I did here is we started with having some tap water heated, and it shouldn't be boiling really hard. It should be just like that. So keep controlling the temperature, don't overheat it. And while it was heating, I went ahead and measured 0.1 gram of each substance. So I have here the three first test tubes are resorcinol, the next three are naphthalene, this substance is benzoic acid, and the last three are acetanilide. So what we're going to do, we're going to see if they dissolve their solubility in water, in 95% ethanol, and in petroleum ether. So to be consistent, I prepare them. So my first is going to be water. So in each of the first sample of each substance, I'm going to just put 1 milliliter of water. And 1 milliliter is about a pipette full. So 1 milliliter of water in the resorcinol, 1 milliliter of water in the naphthalene, 1 milliliter of water in the benzoic acid, and 1 milliliter of water in the acetanilide, which is this one. Okay, so now we have the first sample has water, and we want to see how they dissolve in water. Now in this lab, don't put a stopper to shake. Make sure you use a clean glass rod and try to shake it to see if it dissolves in the water. So you see already that resorcinol is completely soluble in cold water. So we don't need to heat it here. Then I'm going to clean up my rod. And it's always a good idea to have a beaker for waste. Make sure you clean it as best as you can and wipe it dry. And then you're going to look at naphthalene. I already see that naphthalene is not soluble. So I'm going to try to dissolve it. But if you look at the structure of naphthalene, it's a completely non-polar substance. So it's obvious that it will be hard for naphthalene to dissolve in water. So what you do, if it doesn't dissolve, put it in water and wait and see if it dissolves eventually. Then the next one is benzoic acid. So here's my benzoic acid. They all have 0.1 grams of the substance, and they all have 1 milliliter of the solvent. So you stir with the stirring rod, and it's obvious that it's not dissolving here. So what I'm going to do, and I already have them marked, this is a different, that's naphthalene, this is benzoic acid. I'm going to leave them in the hot water and see if they dissolve in hot water. Then the last sample is acetanilide right here. So we're going to try to dissolve it same way. And it's obvious it doesn't look like it's dissolving. And if it doesn't dissolve again, you put it in hot water and wait. And I know it's my number one. So we're going to wait a little bit and stir again each of them in the hot water. So this was my naphthalene, and you see it condenses on the stirring rod. So it kind of dissolved, but it also condensed in my stirring rod. So I have to put it back to hot water So it is kind of soluble, but not very soluble. This is benzoic acid, and it's not dissolving much, but we'll wait. And this is the acetanilide. Now, one thing that can happen in the process here is that as you heat it, you might lose some of your water. So it's a good idea to have a little bit of hot water on the side to keep adding in case it evaporates. So it takes a little patience to wait and see. The idea is to make sure you don't have too much water evaporating so that you're consistent with your observation. So for every sample, you have about the same amount of the sample and about the same amount of the water. So here's the naphthalene, and I don't know if you see it well, but it's oily. It's almost like it melted. It didn't dissolve. It feels like at the bottom here, it's accumulating. And so naphthalene is not that soluble in hot water. Cold water, it's not at all, and hot water, maybe tiny bit, but not really. Benzoic acid, though, feel like we need to add a little bit more hot water. But benzoic acid, if it doesn't dissolve, by the way, it means you probably didn't have enough water, so you really need to reach that saturation level. So you don't just give up and say, okay, it's not soluble. Add a little bit more and see if it dissolves. And make sure, of course, your solution is hot. So the acetanilide looked like it dissolved, but we have some kind of impurity down here, but it dissolved in hot water. And benzoic acid needs a little bit more heating, I guess, because we needed a little bit more water in there. So we'll wait for that, but then in the next step, we're going to do the same thing with ethanol. Now, I want you to think about this. What is the difference between a water molecule and ethanol? And of course, solubility has to do with the rule like dissolves like, meaning polar dissolves polar, nonpolar dissolves nonpolar. So alcohol and water are very compatible, so maybe we should expect similar results. So here we go. I'm going to put 1 milliliter of alcohol in my first substance, 1 milliliter in the second, 1 milliliter in the third, and 1 milliliter in the last. So the first is resorcinol, and we saw how it dissolved in water, and we're seeing here that it is also, it's a little less soluble than in water, but it's still soluble in cold water. So resorcinol dissolves in cold ethanol. So it dissolved in water and it dissolved in ethanol without heating. Now let me go back to benzoic acid. I just want to show you that it's dissolving. So benzoic acid dissolves in hot water. So we'll put it back here. That's our benzoic acid. Now, this is naphthalene in alcohol. We saw that it doesn't dissolve in water. And since alcohol and water are similar, we should expect similar results. So it doesn't look like it's dissolving in cold alcohol. I'm going to stir it a little bit with the stirring rod. Make sure your stirring rod is always clean. And just like we did before, if it doesn't dissolve in cold, we're going to heat it a little bit. So I'm cleaning my stirring rod, and we're going to the next substance, which is the benzoic acid in alcohol. So here's benzoic acid in alcohol. I'm going to keep stirring. And it looks like it's soluble, pretty soluble compared to water. So benzoic acid is soluble in cold alcohol completely. Now the last substance is acetanilide. And here we're going to stir it and see if it dissolves. It's better than water. It looks like it's dissolving. So acetanilide dissolves in alcohol. And then we're going to go back to the naphthalene, and you see it is soluble in hot ethanol. Okay? So let's summarize what we've observed. If we look at resorcinol, it dissolves in cold water, so we don't even need to heat it because it will dissolve in hot water. And it dissolves in ethanol. The next substance was naphthalene. Naphthalene is not very soluble in water, but it's more soluble in ethanol when it's hot. Then we go to benzoic acid. We saw that benzoic acid doesn't dissolve in cold water, but it's soluble in hot water, and it takes a good amount of hot water to dissolve it. Benzoic acid is soluble in ethanol, so we didn't even need to heat it, but it was soluble in ethanol. And then acetanilide, we saw that it's not soluble in cold water, but it is soluble in hot water. And then the last one we did is acetanilide in ethanol, and it is soluble in cold ethanol. So these are the results for the two solvents, water and ethanol. The last solvent we're going to do is petroleum ether. So we're going to dissolve we try to dissolve each of these substances in petroleum ether. So just like we did with ethanol and water, we're going to add 1 milliliter of petroleum ether in each. So petroleum ether is a mixture of alkanes, which means that it is non-polar. So let's look at resorcinol in petroleum ether. Cold petroleum ether, we stir and stir and stir. It's obvious it's not dissolving here. So we're going to put it in the hot water for a little bit. Now, one thing about petroleum ether is very volatile, so we don't want to overheat it here because it will evaporate, and you can see it did evaporate. So even if we put a lot, I'm going to add more of petroleum ether, but the nature of resorcinol, the reason that it dissolved in water is probably because it's polar. It's definitely because it's polar, not probably. So because it's polar, it dissolves, and petroleum ether is not polar, so it's obvious that we don't expect it to dissolve. See, it's already boiling over, and it's not dissolved in petroleum ether. Now we're going to go to the next substance, which is naphthalene, and see if it dissolved in cold petroleum ether. So this is naphthalene in petroleum ether. So it's not very soluble, or maybe it is. Let's keep stirring and see what happens. So it's a lot more soluble than in the previous solvents. Now, one problem with petroleum ether, it has the tendency to evaporate quickly, so I'm going to add a little bit more before it evaporates and see what happens. So we can say that it's slightly soluble. It's not completely insoluble. It looks like it is dissolving there, but not completely. So let's heat it up a little bit. And you don't want to overheat it here because, again, petroleum ether, you see, it has very low boiling point. And it looks like it's really dissolving there. So naphthalene is soluble in nonpolar, which makes sense because it didn't dissolve in the water. Then we're going to look at benzoic acid. Benzoic acid right here with petroleum ether. And it really doesn't look like it's dissolving at all. You can see it's kind of a whitish thing. Every time I need to heat it, I'm going to add a little bit more because it evaporates very quickly. So we're going to heat it for a few seconds. And you see it shoots out very quickly. That's the reason you have to be careful when you work with petroleum ether. It's very low boiling point. And again, it's not dissolving. So benzoic acid is not soluble in petroleum ether, both cold and hot. Now the last one is acetanilide in petroleum ether. And of course, you see it's definitely not soluble. I'm going to add a tiny bit more. It's obviously not soluble. Let's heat it a little bit. And it's still not soluble. So, what is the conclusion? In all of these, the only one that was soluble in hot is naphthalene. So that concludes the first part of the recrystallization lab. So today we're going to do the recrystallization of an impure acetanilide. The procedure says to use a 250 milliliter Erlenmeyer flask and to weigh about 1 gram. So let's repeat, how do we use an analytical balance? It's always a good idea to never tear the balance. It's always best to do measuring by subtracting. So you see my balance is reading exactly 0 now. So I'm going to weigh the Erlenmeyer flask and write the mass. So for me it's 100.6724 grams. And then we're going to add 1 gram, about 1 gram. What matters is like you weigh about 1 gram, but you need to know the exact amount you put in your flask. So how do we do this? You always grab a tiny amount with the tip of your scoopula, and you're going to add at the beginning. So for us, 1 gram would be 101. So my balance must read 101.67. So I'm going to keep adding until I get close to 101. And be very careful here because it's very easy to spill chemicals on the balance. That's why I like to take a small amount and get close to the graduated cylinder. Take a little bit at a time. So I'm on 108 here. I want to get 101.67. Now this is 101.01. So when I'm getting close, I bring my hand and start tapping slowly to get the powder go slowly into the flask. And when I'm there, I stop tapping, and then it will give me the amount I want. So I'm still far. Okay, so now I have 101.6311 grams. So I'm good to go. I'm ready. So now that we have our crystals here, we're going to add water, and we established that the water is the best recrystallization solvent for acetanilide. So the procedure says to add 20 milliliters of DI water, and again, this is not really exact because eventually it will evaporate, so the amount of water is not part of your calculation, so don't waste too much time measuring the exact amount, okay? I'm going to put some DI water there, and then you let it heat. You heat it on the hot plate. In the meantime, I have here a beaker with DI water that is boiling. So what is the purpose is so that if my crystals don't dissolve in this amount of water, I have to keep adding more and more water until all the crystals dissolve. So that's how recrystallization works. You have to make sure you create a solution, a saturated solution, so you have to heat it up until all your crystals dissolve when it's hot. So what you do is have to put it on the hot plate, keep on swirling a little bit at a time, and you can tell that this acetanilide is pretty dirty. The amount, we were a little conservative about the amount. You really cannot tell how much solvent you should add at the beginning because it all depends on how much impurity. So it's always a good idea to put less solvent and add as you go than put too much and not know how to take it out or wait until you evaporate it. So here 20 milliliters looks like it's a good amount because it's not dissolving when it's cold. So we're heating it and it looks like it's working its way. If it's not enough, I'm going to use the pipette and add 1 milliliter at a time until all the liquid dissolves. Now what can happen there? You might have some solid impurities that are insoluble, and you might have also some impurities that are soluble and they're colored. So it looks like we're going to have probably both because it looks like our liquid is not completely clear. So we have some colored impurities in there. And if we had solid, insoluble impurity, we will still get rid of it because we're going to have to do some filtration. So first step, as the procedure says, you wait until it's completely dissolved. It's hot and it dissolves. And then once it's all in, we'll go to the second. So it's been a few minutes now since we let it, and you can see that the top liquid is colored and it's clear. But if I show you close up, you see there are a lot of impurities there, insoluble impurities. So what do we need to do? We need to get rid of both the insoluble impurities and the coloration. So to take care of the insoluble impurity, we're going to filter it, of course. But the coloration, when you read the handout, it says if your liquid is colored, use some activated charcoal. Now, how much charcoal do we use? We really need to use the bare minimum. The tip of the scapula, something about this much is good enough. We're going to put it there and then swirl a little bit. Allow the charcoal to absorb these impurities. Now, putting too much charcoal will also absorb your substance. So you want to be very careful. You don't want to overdo it because it will absorb your substance. And then what's the next step? We need to get rid of that charcoal and the insoluble impurities. So we need to do a filtration. Now, what type of filtration? We have to do hot filtration. We need to filtrate it while it's still hot. So what does that take? It takes a little bit of, like, you have to work fast and you have to constantly keep adding hot water. So where do we do it? We use this stemless funnel, because if you use a stem, some of the liquid, the crystals will crystallize in the stem and clog it. So you need a stemless glass funnel, and then we're going to put a little bit of a cotton there, so we call it a cotton plug. Now if you put too much, it will also be like stuck, so it will be clogged, and you don't want that. And if you put too little, some of the crystals might go through. So that's really kind of an art, you know, how much is too much. So here's what I'm going to do. I'm going to take some cotton and put it in there and make sure that it's in covering all the sides, and let's hope for the best. So now I'm ready to filter it while it's still hot. So maybe I can run a little hot water to see how it goes with the funnel. You see here, I'm just putting some water, and you see it's kind of going slowly. So it's going to be a slow process. It looks like I put probably too much cotton, because if it's too slow, it's going to be painful. You're going to have a lot of crystals on top, and you have to keep dissolving and dissolving. So it's best to have a decent flow, but not too slow of a flow. So let's try one more time to have another cotton plug in there. And make sure your hands are clean. I'm using gloves, but just put a little hot water. So this time it looks like it's working better. And make sure your funnel is hot. That's the reason I put it here on this beaker with hot water, is to heat it a little bit so the crystals don't crystallize too quickly. Now I'm ready to filter. Now I have to go slowly, add a little bit at a time, and let it filter. I'm going to switch these. Be careful, don't burn yourself. It's best to probably put some mittens to make sure you don't burn yourself. But the rim of a flask is usually, the rim here is usually a little cooler than the flask itself. So we're still doing this hot filtration. As you can see, it's going slowly. But the good news is, like, the liquid in the bottom has absolutely no color. So it shows that we did, the charcoal took care of the colored impurity. And here's one thing, be careful, don't add too much, because again, you don't want to clog the cotton plug. You want to just add a little bit at a time, and you do the filtration. And of course, in the process of going slowly, you will lose some of the solvents. So that's why it's always a good idea to have some hot water on the side to add the lost solvent that is lost by evaporation. So we're going to keep adding, and this is the trickiest part of the whole recrystallization. This is really the hardest one, because that's where you're going to lose most of your chemicals if you're not careful. So it's really very, the cotton can be too much and it will crystallize on the surface, or you added too much charcoal and it absorbed some of your substance. So that's why recrystallization is really more an art than a science itself. So it takes some practice to get really good at these things. And of course, you know, if you do it the first time, you might be lucky and it works pretty well, but don't feel bad if it doesn't work very well, because that's really what recrystallization is all about. It's really an art, basically. It really takes a practice to get really good at it. And you can see, as I keep filtering, I kept on adding water because I don't want it to run to dryness. And now I'm almost done, so I transferred everything. The last step is to rinse your flask with some hot water. And why? Because we really want to have the maximum recovery here. We want to recover as much as the crystals as we can. And as you can see, every time I add water, it has to be hot, and it has to keep on heating. because if it cools off, it will recrystallize, the crystals will recrystallize immediately. So the amount that I'm pouring here is about like less than an inch above the cotton plug. If you put too much again on that funnel, you will have bad results because a lot of your crystal will crystallize on the top. So far we've been pretty lucky. It worked pretty well. We didn't have any clogging there. And here's my last rinse right there. And of course you're going to have some residue, but it looks pretty good overall. So now, what do we do next? Once we finish that filtration, we're going to rinse one more time the funnel, and then since we added a lot more water than we needed, we need to evaporate it again. So that's also another aspect of recrystallization that's like an art. You have to let it evaporate, and then the question is, how far should I keep going? And we're going to show you how this should work. So one more rinse, and we're good to go. I'm letting this filtrate completely. I'm done with the hot water. I no longer need it. And now that I finished my filtration, if you remember, we started with 20 milliliter, maybe 30 milliliter, but now we're almost like 40. So what we need to do is heat it to get back to 20 milliliters. So about halfway it has to evaporate. So now that we evaporated half the water, you see the minute I put it on the bench and I swirl a little bit, you start to see some crystals will form, and I can see them right away. So you see it looks milky, it looks slightly milky. So that means you really evaporated all the possible water. So that's definitely a saturated solution. So I'm swirling it a little bit to cool it off. So first you cool it off at room temperature, and then you're going to put it in an ice bath. Now in the meantime, what I did is I prepared my vacuum filtration setup, and you remember we did this before in the extraction. So what you do is you make sure you have your trap attached to the vacuum, and then your vacuum flask, and then make sure you have the right filter paper to go there. So this is kind of okay, it's not that hot. I can put in the ice bath, and you let it crystallize for whatever time. Normally a slow recrystallization always produces better crystals, so if we could leave it even overnight covered, we come back and it will develop beautiful crystals. But for the sake of the experiment, we need to just do it quickly, so we can just stick it in an ice bath and wait until pretty much you know that it crystallized when all the crystals are together and almost looks like there is no liquid in there. Ready for the filtration. Remember to filtrate. You open the vacuum, run some water on your funnel, and you can see that it's secured now. And then you're going to filter your substance. Of course, we put here some ice cold DI water. You see your crystals, just make sure you scrape them and get most of them in your funnel. And the idea is to rinse them with ice cold water. And normally less is more, so meaning like you don't want to use too much water. And you want to make sure you scrape all your crystals and transfer them onto your funnel. Now, one thing to remember, that filter paper you should have pre-weighed with the beaker, because at this point we're going to put the substance with the filter paper in a beaker and we're going to let it dry overnight. And then when you come back next time, you just take a melting point and an IR spectrum.